Hi, guys. It's me, Mr. Bertoch, your super-de-duper handsome science teacher. And we, in this video, are going to be talking about the Earth's moon. Well, you probably never noticed this because it's not very obvious. But if you look up at the night sky, much of the month, not all of the month, but a lot of the month, there's this giant glowing thing up there that we call the moon. Well, what in the heckins is the moon, and why is it there? How did it form? And what are the features of the moon? That's what we're going to be talking about in this video. Let's start with what is a moon. And a moon has a very simple definition, the word moon. It's an object in space, a space object, a body in space that orbits another body in space. And that's really it. We think about moons as orbiting planets, and that's typically the case. But moons also orbit some of the asteroids and comets. Okay, not very many, but a few of them do have moons. So a moon is anything that orbits a planet or smaller, right? If it's orbiting the sun, it's something else. It's an asteroid, or it's a planet, or it's a dwarf planet, or a comet. Okay, but if it's orbiting another object at a lower order than the sun, is orbiting something that is then orbiting the sun, then it is a moon. Okay? And the reason that this happens is because of gravity, right? The attraction of gravity, it causes objects to be attracted to each other, just like magnetism or static electricity. And so the objects are attracted because they're like, ooh, you're beautiful. I want to be near you. And they start orbiting the one orbits the other one. Instead of ever talking to it and introducing itself and getting the phone number, it's too shy. So it just orbits around it forever because that's not creepy at all. So that's what a moon is. Well, most moons are significantly smaller than the thing that they are orbiting. And they have to be smaller because it's kind of hard for the gravity of one thing to catch something else. In order for the gravity of and this is why so few asteroids have moons, because the conditions have to be just right. Okay, in order for one object to catch or capture a moon and get it to orbit around itself, usually the object that's being orbited, that's capturing the smaller object, it has to be much bigger than the other object so that its gravity can have enough strength compared to the gravity and the size and the mass of the smaller object to hold on to it. And the second thing is the other object needs to not be going too fast. Otherwise, it's just going to zoom right by and fly away and escape, and it won't get to orbit forever. So the conditions have to be just right in order for a moon to be captured. And that usually means that the object that's orbiting is much smaller, much smaller than the object being orbited. Well, here's the dealio. The Earth and the moon are not that different in size. The moon, the volume of the moon, is only about 25% that of the Earth. And that's a pretty close size. And that's pretty unique. Okay, there's only one other place in the solar system where we see that. And that would be between the dwarf planet Pluto and its moon Charon. So how did that happen? How did the Earth end up with this huge, humongous moon compared to itself? let's think about the size of the Earth compared to the other planets for just a minute. So there are 4 other planets that are larger than the Earth, and they are significantly larger. Those would be the 4 gas giants, which are Jupiter, Saturn, Uranus, and Neptune. Okay, and Jupiter alone is like 1,000 times bigger than the Earth. And these planets, some of them, do have moons that are larger than our moon, larger than the Earth's moon, but not very much larger. So, for example, Jupiter has a moon called Ganymede, and it is bigger. There are actually 4 moons that are bigger than the Earth's moon, but not by very much. They're just a little tiny bit bigger than our moon. And even though Jupiter is 1,000 times bigger than the Earth, its biggest moon is just a little bit bigger than our moon. Okay, so that's pretty important to understand because it gives you a sense for what weird, strange things must have happened as the moon formed in order to allow us to have this ginormous moon compared to the size of the Earth, that 1-to-4 ratio that where we talked about a minute ago, that the moon is a fourth the size volume of the Earth. That's very unusual. That's not very common. Well, what happened? Well, we're not really sure because the guy who was alive back then didn't take any videos, and actually no one was alive back then because the Earth hadn't formed yet. But so we don't have any record. Okay, we have no way of going back. There is no way of going back and seeing what happened. So we have to infer, and we try our very best to come up with theories, which may be totally wrong, but they're pretty good theories based on the evidence that's out there. So the leading theory, and there is a lot of evidence for this, is that as the Earth was forming way back billions of years ago in the early solar system, you have this baby Earth that is developing, and it's still mostly a ball of fire, lava, not really fire, but magma, and it's starting to cool down. And along comes this other planet, and this other planet is like, ooh, I want to meet you. And so it comes along, and it instead of orbiting it, because it's way too big, and the Earth can't capture something that big, well, what does it do? It smashes into the Earth. It's like, hello, and they collide, and bam, there's a big explosion, and debris goes everywhere, and it completely destroys the smaller world and nearly destroys the larger world. But out of the ashes, so to speak, of that catastrophe, then all of that matter over millions and millions of years slowly coalesces back into the Earth as it comes back in under the force of gravity. And some of it, a lot of it, stays in orbit around the Earth and forms a ring. So kind of like Saturn for a while. And then ultimately all bunches back up into, it is gathered into around the orbit of the Earth into the moon. And so because of that catastrophe, we end up with a very, very large moon compared to the size of the Earth. Now, that may not actually be what happened, but it's very difficult to come up with another theory for how such a thing could happen, how we could end up with such a large moon under any other circumstances. Maybe, though, someday, being the very smart person that you are, you'll come up with another theory, and everyone will be like, oh, I never thought of that. That is the correct theory. But for now, our best understanding is that the moon formed because of a ginormous collision between 2 forming planets. 2 planets actually collided, and the debris from that over millions of years coalesced back into 2 worlds. And many scientists, by the way, consider the moon and the Earth to be a twin planet rather than like a binary planet. Okay, there's many stars that are binary stars, where there's 2 stars that orbit each other. There's 2 suns in that system. Okay, and many scientists consider the Earth and Moon to be a binary planet because of how large they are compared to each other. This large size compared to the size of the Earth results in certain unique things that occur on the Earth. The moon actually impacts us and impacts all things, all living things here on the Earth in interesting and predictable ways. Now, I'm not going to go through these in this video other than to mention them. I do teach these concepts, teach about these phenomena in other videos, but let's just briefly mention them. So one of the things that happens are ocean tides. The moon causes the water to move around the Earth. And another thing is that the Earth, or the moon rather, offers protection to the living things on the Earth by blocking all of the not all, but some of the incoming comets and asteroids that hit the Earth. It kind of helps to protect us, both physically, but also just by its gravity, flinging those objects away, helping to keep them away from us. Okay, there are solar and lunar eclipses that you can see with your wee own little eyes from the Earth, and there are lunar phases. So again, all of those things I cover in other videos, but they're interesting phenomena that result from having a moon that is super duper large that aliens and other planets don't get to necessarily experience unless they happen to have a moon as big as compared to their planet as we do. And lastly, let's talk about some of the features and facts about the moon. So first of all, we've talked a lot about the size of the moon, but what exactly is the size of the moon? So it turns out that the moon has a diameter, which is the distance around the moon of 2,160 miles. Okay, I'm a mile person. Some of you are kilometer peeps. And so for the kilometer peeps, and I'm totally going to cheat and look at a paper because I don't know the kilometers. It's 3,476 kilometers. Okay. So the distance of the moon. Now, this is going to sound like a big number, but compared to outer space, it's teensy tiny. Okay. The distance of the moon from the Earth is roughly about 239,000. It's 238,900-ish miles. And in kilometers, for the kilometer peeps, it is 384,472. Okay. And when you look at the moon, like if you take some binoculars, and I would really encourage you to do that, by the way, because it's really neat to see the moon through binoculars. There's so much detail you can see just with a pair of normal binoculars. When you look at the moon, even with the naked eye, though, you're going to see dark splotches and lighter splotches. The darker areas are parts of the moon. They're older parts of the moon where the landscape has not been disrupted for a very long time. The lighter splotches are areas that we call mare, or plural would be Maria. And the mare, a mare, or the Maria, that word, by the way, means sea. So some of the ancient observers thought maybe there were seas on the moon because those areas, they look flatter and lighter. Well, they're not. They're not water. They're seas in a way, though. They're seas of basalt, which is basalt just means lava rock. Okay, those are ancient volcano eruptions where lava came out and covered the older landscape over with newer, fresher ground. Now, it's still billions of years old. There hasn't been any volcanic activity on the moon for billions of years, but those areas are newer landscape and flatter, have fewer craters there, and they're a little bit lighter color. So, and speaking of craters, that's something else you can see, especially if you get your binoculars out. This is something I would highly encourage you to do. Look at the moon. As you're watching the moon, and if you're looking for craters, look to the edge of the visible light. If it's, for example, let's say it's a waxing gibbous moon. Okay, if you look at the edge of that line where the light and darkness meet, it's a really good place with a pair of binoculars to be able to see the craters, because the light and the shadows make it a lot easier to spot craters there. But craters are places where the moon has taken a beating from outer space. asteroids and comets and things have come in and said pow and punched the moon right in the face and left a mark. Hi guys, thanks for watching my video. These rambling science videos where I go unscripted and just kind of barf up all the science knowledge out of my head are part of a series that go along with an online class that I teach, which you can sign up for if you go to handsomescienceteacher.com. I also have a whole bunch of free resources for homeschoolers. I have hundreds of articles on every topic that covers your entire science curriculum from 5th through 8th grade. I have online games and quizzes, all curated and written by this handsome guy, a science teacher with, well, three degrees, but 2 of them are in science. So it's targeted right to and directly to your science students. So sign up, subscribe to the channel, and I release lots of videos. Also, in addition to these ones, lots of little short videos that are like 2 minutes long that cover science topics. Those ones you don't get to see my handsome face, but they're still good videos and they're much more targeted, and those ones are scripted, so you don't have to hear me like you are right now going blah blah blah. The end. Subscribe. Thank you. Goodbye.